Hello everyone. So I will try to make some video tutorial about the ESP32, especially how to use MCPWM to make some PWM, because based on my experience is this module have a very little tutorial in everywhere how to make it from basic, especially with ESP-IDF version 5.4. So if you open the documentation in here, we will find this diagram. Actually, this module is made for motor control purpose, but because it have so many features that very useful for another things, like deadtime compensation, and then the carrier modulation, like you can make it complementary or passive like that. So this is very useful, we can use it. So I will give some explanation and some code how to use it by based on my experience. Actually, there is some example code that you can get directly from the ESP-IDF GitHub, like in here, like in example, and then peripherals, and then you go to the MCPWM. So for the ESP-IDF, for the ESP32, you have two options to generate the PWM. You can use LEDC module or MCPWM. So in here, I think all of the example is not easy to understand, because the example is based on some application, not a basic generation for PWM. So yeah, it's very hard for me to understand it before. So I try to make this video. So basically, to use this module to generate the PWM, you need to do 6 steps of generation. So I made this one based on my experience. So you need to generate the timer, the operator, comparator, generator, and then you need to configure the modulation, and finally you need to start the timer and the PWM. And then we go to the code. So this is the basic code how to generate the PWM using this module. I will put in GitHub with another example, but I will explain it in here. But not so detailed. So first you need to generate the timer. So the timer is in here. You can write the code like this, and then to configure the timer, you can change the configuration in here. So in here the clock source is the clock source default, or in here is around 160 megahertz. And then the next one is the resolution. So the resolution is like a prescaler for the clock source. We can put same like the source clock source up to 160, or you can use it lower. In here I take around 20 megahertz to use it. And then the next one is the count mode. So this will be decide how the timer works. You can the timer can be start from 0 and increase until maximum value, and then restart again from 0, or you can start it from the maximum value and then decrease until 0 and directly restart again to maximum, or you can make it like is increase from 0 until maximum and then decrease until 0 again, so it will be like a triangle. So there is 3 mode for the count mode. And then the next one is the periodics. So the periodics is how many ticks that for every full resolution. Like in here, example 20 megahertz. So if we have 1000 ticks on 20 megahertz, we will divide it 20 megahertz divided by 1000, we will get 20 kilohertz timer. So this ticks and resolution will be decide the frequency of your PWM. So you can change these two to get based on your needs. You can make the resolution higher and then the periodics higher to make the PWM have a higher resolution, or you need a faster PWM, but by lowering the periodics you can do it by changing these two. And then the next one is the operator. So the operator in here will be I think will be decide for each PWM pin generation. So I mean that if you want make 2 pins of PWM that complementary, you can use one operator, a single operator. It means that 2 PWM will be dependent each other, so it will be not independent. So there is no isolation between 2 of them. So if the duty cycle one of them changes, the other will be changed too. So you just need assign one changes to control 2 PWM. But if you want to make 2 dependent PWM, you need to assign 2 different operator. But in here I will right now we will try with one operator, single operator. But for the code that I will upload to GitHub, it will be have more than one operator. And then the next one, we need to configure the comparator. So the comparator, same like operator. If you have different operator, it means that if you have more than one operator, it means that you need create 2 comparators. So the number of comparator will be depend on the number of operator. Because in here I use a single operator, so I only need to make one comparator like this. And then there is some configuration that you can change, like when you want to update the value of the comparator, because the comparator in here, this value will be decide the duty ratio of your PWM. So this value, the maximum value, should be equal of your periodics in here. So if we put like 1000 in here, it means that you will generate 100% duty ratio on the PWM, or it means that it will be on high state or full on for every cycle. So if we put 500 in here, it means that because 500 divided by 1000 is 0.5. It means that it will generate 0.5 duty ratio or 50% duty ratio for your PWM. So right now we put 500, we will generate 50%. And then the next one is the generator. So the generator, in here, the number of generator, the number of generator will be depends on how many pin that you will generate for PWM. I'm sorry, how many pins that you use for PWM. So if you have like 4, 5 or 6, it means that you need to generate 6 generator. So in here I will use single generator because I only put PWM on pin number 18, GPIO number 18. So the code is like this, and then after that we need to configure the action for the generator. So there is 2 different action. You can base on the timer or you can base on the comparator value. But in here I will give some example like a usual PWM. So in here it's called set action on timer event. It means that it will be based on the timer. So what is on based on timer? The generation for the low state on the high state. I'm sorry. So when the timer is going up, so the direction should be going up because we use count mode direction up. So when the timer is equal 0 or empty, the generator should be make the pin on to be high state or turn on. And then for the next one in here will be set action based on compare event, so based on the comparator. So we will compare the value of the timer and then the comparator, and then if the both value is equal, we will do something. The generator will be do something. So same direction going up, and then if the value is same with the comparator, if the timer is same with the comparator, we will turn off the pin or make the pin to be low state. So will be like this. And then the next step, the last step, is we just need to turn on the timer and then put the timer to be start. Okay, so we can try to build. So before we flashing it, I already put some oscilloscope probe to pin number 18 and 19 because on the next step I will show how to make a complementary mode PWM. So like this, and then I will use this oscilloscope, so portable oscilloscope that connect to my laptop, so we can see the waveform directly. So we just flash it. Oh yeah, don't forget, so in here ESP-IDF version 5.4. Okay, we already flash it, and then you can see the result on the right top side. I will make it larger. So channel 1 is pin number 18. So there is a PWM in here with 50% duty cycle, and then we can see the frequency is 20 kilohertz. Okay, so the next step is I will make it another pin to be PWM, same with pin number 18. So we're going back to the code. Because we will depends on the same timer, same operator, and then same comparator, we only need to adding another generator. So we make this variable to be array with two data, and then we put another pin 18 and 19 in here, and then we need to assign the configuration to each generator and then operator by using a recursive function using for I equal 0 and I to be less than equal 1, I plus plus. And then this should be I, and generator number should be like this. So for every step, it will be assigned the pin to each generator. So, and then in here we need to make two configuration for each generator. So this is for the first generator, and then this one for the second generator. So don't forget, array is start with 0 because it's array. So after this, so we just need to build. Okay, let's see what happened. Then GPIO is pin 19. Wait a moment. Oh, I forget to put the array value like this. Okay, just build. And then after build, we flash it. Okay, so we can make it larger oscilloscope. Okay, right now we have two PWM on two different pin. So pin 19 and I mean pin 18 and 19, both of them with same frequency and same duty cycle, because both of them depends on same timer and same operator, like this. Okay, so we're going to the next step. I will make for the pin 19 for this blue channel to be the inverse of the pin 18. So I will make it complementary. So we're going back to the code. So to make it complementary, we can depends on only one setting like this in this module in MCPWM, but we need to make some add-on by using deadtime. So I already have some code to use it. So we'll copy it to here. Yeah, like this. So if you read in here, I write something. That time only can be assigned to one positive edge or negative edge for both PWM on the same operator. It means that you can set like this for if you want to set positive edge and negative edge for one pin, for pin like pin number 18, it means that you cannot set it for pin 19, so you need to split into two. Like in here I put some delay to pin number 18 to positive edge delay, so when rise time I put some delay, and then I put some another delay on the falling time, but for pin number 19 like this. And then this function will be decide it will be invert or not. So if you want to make it the pin is both of pin is complementary, so you need to assign true value in here. And then don't forget, you need to make it like this. So generator 0 to generator 0, it means that the input generator 0 and the output is generator 0 for the datetime, the first configuration for this configuration. And then the second one, the input will be generator 0 and the output will be for generator 1. It means that the input signal will be from generator 0, but it will be input into the datetime module that will will be made some modification onto signal, and then output for control the generator 1, which is pin number 19. That's why you don't need to configure another generator in here. We just need to configure one generator, in this case generator number 0, and then it will be directly controlling generator number 1. And then like this we just build. Okay, after we build, we flash again. Okay, so we're going back to the oscilloscope. Okay, right now we can see that the blue waveform is the inverse of the yellow. So yellow is pin number 18 and the blue is pin number 19. You can see right now both of them is complementary. And then if you zoom in the waveform, it should be have some dead time. So I'm sorry because my oscilloscope is not that good, it's not that fast, so yeah, it's not very clear. But in general we can see there is some delay from the dead time module. So yeah, I already give some example and some explanation for the code. And then actually I already made another code that have a full explanation about this, about the configuration. So this is only the basic stuff, but we'll open another code that I will upload to the GitHub. Wait a moment. So it should be this one. So I already make the code with different condition that you can just uncomment and try it. So in this example, 1 timer example, 2 timer, and then 1 operator, or you can use 2 operator, and then comparator, assign each comparator, yeah, like this. And then all of the configuration that you can use for your needs, you can try it. This code I will upload it to GitHub, and you can use it for your need. Okay, maybe only that's all that I will explain about this video. So thank you very much, and hope best day for you all. Thank you.